Welcome to Mathematics for All by Neomath. Today we are going to discuss Class 9 NCERT Mathematics Chapter 2 Polynomials Introduction to Exercise 2.3. Topics to be covered: Arithmetic division, Properties of polynomial, Polynomial division by monomial, Division algorithm for polynomial, Remainder theorem. The first topic we are going to discuss is arithmetic division. Let us consider two numbers 15 and 6. We divide 15 by 6. 15 is the dividend, 6 is the divisor. 6 into 2 is 12. So subtract 12 from 15, we get 3. So the number which we divide is called the dividend. Here 15 is the dividend. The number by which we divide is called the divisor. 6 is the divisor. The result obtained is called the quotient. Here 2 is the quotient. The number left over is called the remainder. 3 is the remainder. So dividend equal to 15, divisor equal to 6, quotient equal to 2, remainder equal to 3. We know that the relationship between the dividend, divisor, quotient and remainder. Dividend equal to divisor into quotient plus remainder. Add the remainder with the product of divisor and quotient. The sum we get should be equal to the dividend. Now let us verify the answer. 15 equal to 6 into 2 plus 3. 6 into 2 is 12. 12 plus 3 is 15. So the answer is correct. Similarly, we divide 12 by 6. 12 here. 6 is the divisor. 6 into 2 is 12. Subtract, you get 0. So dividend is 12, 6 is the divisor, 2 is the quotient, remainder is 0. Let us verify the answer. 6 into 2 plus 0, we get 12. So the answer is correct. Here 12 is a multiple of 6 and 12 is a multiple of 2. So 12 is a multiple of 6 as well as multiple of 2. 6 is a factor of 12 and 2 is the factor of 12. So 6 and 2 are factors of 12. Can we divide one polynomial by another polynomial? Yes, we can. Before starting, we will discuss the properties of polynomial. Properties of polynomial. Polynomial plus polynomial, we get a polynomial. When you add two polynomial, the resultant is also a polynomial. For example, 4x square, I am adding two monomial. So 4x square plus 2x, we get 4x square plus 2x, which is a polynomial. The powers of the variable are a whole number. So 4x square, the power of the variable is 2, which is a whole number, and 2x, the power of the variable x is 1, so that is also a whole number, so it is a polynomial. So when you add two polynomials, the resultant is also a polynomial. When you subtract a polynomial from the polynomial, the difference is also a polynomial. For example, 4x square minus 2x, we get 4x square minus 2x, because these two are not like terms. So we get 4x square minus 2x, which is a polynomial. When you multiply a polynomial by a polynomial, the resultant, the product is also a polynomial. So 4x square into 2x, we get 8x cube. When you divide a polynomial by polynomial, you may or may not get a polynomial. Division of polynomial by polynomial. Here the divisor is a monomial. Here we have three cases. Case 1, when degree of numerator is greater than degree of denominator. Case 2, when degree of numerator is equal to degree of denominator. And case 3, when degree of numerator is less than degree of denominator. Let me check one by one. Case 1, when degree of numerator is greater than degree of denominator. For example, 4x square by 2x. How can we find out the degree of the polynomial? Degree means it is the highest power of the variable. In the numerator, we have a polynomial 4x square. So the degree is 2 and the degree of the denominator is 1, isn't it? So 4x square by 2x, we get 2x, which is a polynomial. So polynomial divided by polynomial, the resultant is a polynomial. when degree of numerator is equal to degree of denominator. This is the second case. For example, 2x by 2x. So both the degrees in the numerator and denominator are 1. So 2x by 2x we get 1, which is a constant polynomial. So polynomial divided by polynomial is a polynomial. Third case, when degree of numerator is less than degree of denominator. For example, 2x by 4x square. So the degree of the polynomial in the numerator is 1 and the degree of the polynomial in the denominator is 2. So we get 1 by 2x. 1 by x can be written as x power minus 1. So 1 by 2 x power minus 1. The power of the variable is not a whole number. Minus 1 is not a whole number. So this is not a polynomial. So polynomial divided by polynomial. In this case we are not getting a polynomial. So polynomial divided by polynomial, here it is not a polynomial. Let us divide the polynomial 2x cube plus x square plus x by the monomial x. So 2x cube plus x square plus x, the whole divided by x. So we get 2x cube by x plus x square by x plus x by x. 2x cube by x we get 2x square plus x square by x we get x plus x by x we get 1. You may have noticed that x is common to each term of 2x cube plus x square plus x. So we can write 2x cube plus x square plus x equal to x into 2x square plus x plus 1. So 2x cube plus x square plus x is a multiple of x as well as multiple of 2x square plus x plus 1. And x and 2x square plus x plus 1 are factors of 2x cube plus x square plus x. Sometimes it is better to use long division method for the division of polynomials. It is similar to long division for numbers. So the next topic is division algorithm for polynomials. Polynomial long division is a method for dividing a polynomial by another polynomial of a lower degree. It is very similar to dividing numbers. Division algorithm for polynomials. Step 1. Write the dividend p of x and divisor g of x in standard form. How can we write in standard form? By arranging the terms in the descending order of their degrees. Sometimes there can be missing terms. In that case, either leave gaps or include the missing term with a coefficient of 0. So for example, p of x is equal to 3x cube plus x minus 1. This can be written as p of x is equal to 3x cube plus 0x square plus x minus 1. Let us consider an example to see how we can divide a polynomial by any non-zero polynomial. Step 1. Write the dividend p of x and divisor g of x in standard form. Here p of x is equal to x plus 3x square minus 1. G of x is equal to 1 plus x. These two polynomials are not in standard form. So we have to write these two polynomials in standard form by arranging the terms in the descending order of their degrees. So p of x is equal to 3x square plus x minus 1. And g of x we have to write as x plus 1. So next, step 2. Divide the first term of the dividend by the first term of the divisor. First term of the dividend divided by the first term of the divisor, we get the first term of the quotient. P of x is equal to 3x square plus x minus 1 and g of x is equal to x plus 1. The first term in p of x is 3x square and the first term in g of x is x. So 3x square by x is equal to, we get 3x. 3x square by x can be written as 3 into x by x. X and x get cancelled, we get 3x. Step 3. Multiply the divisor by the first term of the quotient. Divisor into first term of the quotient. So here divisor is x plus 1 and first term of the quotient is 3x. When you divide, you get 3x into x, 3x square plus 3x into 1 is 3x. Step 4. Subtract this product from the dividend. So first set up the division, long division, 3x square plus x minus 1 and divisor x plus 1. So first you have to divide the first term of the dividend by first term of the divisor. 3x square by x, we get 3x. Then multiply the divisor by the first term of the quotient, we get 3x square plus 3x. Here 3x square plus x minus 1 is the dividend, x plus 1 is the divisor, and 3x is the first term of the quotient. So now we have to write the product of the divisor and the first term of the quotient. So change the sign. Now subtract 3x square minus 3x square get cancelled, plus x minus 3x we get minus 2x, and bring down minus 1. This is remainder. So step 5. If degree of the remainder is greater than or equal to degree of the divisor, then treat the remainder as new dividend. Here the degree of the remainder minus 2x minus 1 is 1. The degree of the divisor x plus 1 is 1. So the degree of the remainder is equal to degree of the divisor. Then we have to treat this remainder minus 2x minus 1 as new dividend. Step 6. Repeat division step 2, step 3 multiplication and subtraction step 4 using new dividend. So we have to repeat the division, multiplication and subtraction using the new. So step 6. First term of the dividend by first term of the divisor is equal to second term of the quotient. So first term of the dividend is minus 2x, which is the new dividend, and first term of the divisor x. We have to take the same divisor. Minus 2x by x, we get x. We get minus 2. So minus 2 is the second term of the quotient. Step 7. Multiply the divisor by the second term of the quotient. X plus 1 into minus 2. We get minus 2x. X into minus 2 is minus 2x, plus 1 into minus 2 is minus 2. Step 8. Subtract this product from the dividend. So minus 2x minus 2. Change the sign. Now we get minus 2x plus 2x get cancelled. Minus 1 plus 2 we get 1. Now 1 is the remainder. So here degree of the remainder is less than the degree of the divisor. Degree of the remainder is 0 and degree of the divisor is 1. So degree of the remainder is less than the degree of the divisor. So we have to take remainder. So 3x square plus x minus 1 is the dividend, x plus 1 is the divisor, 3x minus 2 is the quotient, and 1 is the remainder. We know that dividend is equal to divisor into quotient plus remainder. So dividend is 3x square plus x minus 1 and divisor is x plus 1 into quotient 3x minus 2 and remainder is 1. So x into 3x, x into 3x is 3x square, then x into minus 2 we get minus 2x. Next 1 into 3x, so 1 into 3x is plus 3x, then 1 into minus 2 we get minus 2 plus 1. Next 3x square, these two are like terms, isn't it? So minus 2x plus 3x we get plus x. 3 minus 2 is plus 1, then minus 2 plus 1 is minus 1. So here you check the LHS. 3x square plus x minus 1 equal to 3x square plus x minus 1. So LHS equal to RHS. If p of x and g of x are two polynomials, p of x be dividend and g of x divisor. Okay, so if p of x and g of x are two polynomials such that degree of p of x is greater than or equal to degree of g of x, that is degree of dividend is greater than or equal to degree of divisor g of x, and g of x is not equal to 0, that is the divisor is not equal to 0, then we can find polynomials q of x and r of x. Q of x is the quotient and r of x is the remainder, such that p of x is equal to g of x into q of x plus r of x. We know the relationship between these. Dividend is equal to divisor into quotient plus remainder, where r of x is equal to 0, that is remainder is equal to 0, or degree of r of x is less than degree of g of x, that is degree of remainder is less than degree of g of x, that is divisor. So if p of x and g of x are two polynomials such that degree of p of x is greater than or equal to degree of g of x and g of x is not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. So this is the division algorithm for polynomial. We can find out remainder using two methods. When you divide 3x square plus x minus 1 by x plus 1, we get 1 as the remainder. So this is long division method. And the second method, you have to find the 0 of the divisor. Here the divisor is the linear polynomial. X plus 1 is a linear polynomial. Linear polynomial means if the degree is 1, then it is linear polynomial. So degree of x plus 1 is 1. So the 0 of x plus 1 is minus 1. So how can we find out x plus 1 equal to 0? You have to equate it to 0. X plus 1 equal to 0. X is equal to minus 1. So the 0 of x plus 1 is minus 1. Isn't it? So if you substitute, if you replace x by minus 1, we get 0. This polynomial, linear polynomial becomes 0. So the 0 of x plus 1 is minus 1. So now you have to replace x by minus 1 in p of x. P of x is 3x square plus x minus 1. So p of 1 is equal to 3 into minus 1 the whole square plus minus 1 minus 1. So 3 minus 1 minus 1, we get 3 minus 1 2, 2 minus 1 1. So here p of 1 is equal to 1, which is equal to the remainder obtained by actual division. Isn't it? So now we are going to generalize this fact in the form of remainder theorem. Now we discuss remainder theorem. Let p of x be any polynomial of degree greater than or equal to 1. So the degree of polynomial is greater than or equal to 1. And let a be any real number. Okay. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. P of x is equal to g of x into q of x plus r of x. This is the relationship between dividend, divisor, quotient and remainder, where r of x is equal to 0 or degree of r of x is less than degree of g of x. So here dividend is p of x, divisor is x minus a. Let p of x be any polynomial of degree greater than or equal to 1 and let a be any real number. If p of x is divided by x minus a, so p of x is equal to x minus a into q of x plus r of x. So dividend is equal to divisor into quotient plus remainder. Here divisor is x minus a. Then we get quotient q of x and remainder r of x. The degree of the divisor x minus a is 1. So the degree of remainder should be less than degree of divisor. So degree of remainder is less than 1 because the degree of divisor is 1. So the degree of remainder should be less than degree of divisor. So it should be less than 1. So the degree of remainder is 0. If it is 0 means remainder is a constant. So P of x is equal to x minus a into q of x plus r. P of a, replace x by a, we get a minus a into q of x plus r. A minus a is 0. So 0 into q of x becomes 0. So 0 plus r, we get r. So P of a is equal to r, which proves the remainder theorem.